Hello and welcome to this session. In this session, you will learn how to represent the integer data, the various modifiers used along with integer data, and how to represent integers in the memory. You will also learn about the usage of variables and their naming rules and how to define and declare these variables. Data representation in computer is dependent on the word size of the machine. This helps the machine to represent specific data to occupy certain range of values. As we understand that there are different kinds of data such as integers or float values or characters that we use, this word size allows us to further understand what a range of values a specific data can occupy within the computer's memory. One such data being integer, integers can be defined as whole numbers with a certain range of values, with specific range of values. Now these integers can further be classified as signed numbers and unsigned numbers, or signed integers or unsigned integers. Signed meaning which are the numbers which are represented using sign, which can be positive numbers or negative numbers. Unsigned meanings which the numbers which do not have any specific sign, particularly whole numbers. How much memory can be occupied by an integer type is always dependent on the machine's configuration. Integer type can occupy from 2 bytes to 4 bytes to 8 bytes of memory. Now this always depends on the processor which allocates the memory. A 16-bit processor will usually allocate a 2 bytes of memory for an integer value. A 32-bit processor will allocate 4 byte of memory to an integer value, and a 64-bit processor will allocate 8 bytes of memory for a integer value. As it is known that integers will occupy certain range of values, C language allows us to alter this range by adding certain type modifiers. Now, the type modifiers alters the meaning of a base type to fit into our need more precisely. Now, the modifiers that we can see here are short and long, which are usually preceded before the data type that we use. Now, short here will have the lesser range of values than int, and long has the higher range of values than int. This table represents the kind of modifiers that are used along with the integer type. Here in the table, the first column represents the integer type along with the modifiers like int or signed, or shortened or signed shortened, or longint or signed longint. The second column represents the number of bits that are occupied in the memory, and the third column represents the range of values. Now, the word size depends on the machine. It is usually said that the integer data type occupies 2 bytes of data in the computer's memory. 2 bytes meaning 1 byte has 8 bits, 2 bytes has 16 bits of data. Now, when we say bits, it is nothing but a binary digit. A binary value can either be 0 or can be 1. Every information in the computer's memory is stored in the form of a binary value, whether it is an alphabet or a character, or it can be anything. Now, coming back to the table here, now as we say that as we can see unsigned int here. Now unsigned int has a size of 16 bits, or it can occupy 16 bits of memory, which ranges from 0 to 65,535. Now this is calculated by calculating 2 to the power of 16. 2 raises to 16 will give 0, 65,536. That's the value. So the range of values that you can have is from 2 to the power of 0 to 2 to the power of 16, minus 1, which is usually for sign that we say. So we can have 0 to 65,535 range of values for an unsigned int. For a signed int or for just a normal int, it can be both. It will have the range of values for negative numbers as well as positive numbers. So half of 65,535 will be negative range of values, half of 65,535 will be range of positive values. So the range of negative values for a signed int will be minus 32,768 to 0, and the positive values will be 0 to 32,767. The same holds good for short int, which occupies 8 bits because it will occupy lesser range of values than integer. For long int, it would be 32 bits because it will occupy higher range of values than the integer value. A doubt that may arise uh, while using these integer values and fractional values is, can we assign fractional values to integer type, or can we store fractional values into integer type? Though we might assign a fractional value to integer type, it will not be stored in memory as fractional value, but it will be truncated. That is, all the values after the decimal point will be truncated and will again be stored as an integer value. Having said that, we can always store an integer value by using float data type, but we cannot uh, store a fractional value using an integer data type. A variable is nothing but whose quantity may vary during the program execution. The names that are given to the computer memory location are nothing but the variable names, where we store different constant values such as integer constants or real constants, etc. Now, a constant stored in a location with a particular type of variable name can hold only that type of constant. For example, an integer variable cannot hold float values. An integer variable can store only integer values. Now, the general syntax of variable declaration is type, that is the type of variable, followed by the variable list, where we can have more than one variable in a single statement. Now there are certain rules that are followed while naming the variables and assigning them the values. Now the first rule says that every variable name must begin either with a letter or with an underscore. Now the first example, area, is begin with a letter A, which is a capital letter. We can also use a smaller case letter or a lower case letter while naming. The second example, in second example, uh, area has begun with, or the variable name has begun with underscore, which is also a valid variable name. The next rule says that variables are case sensitive, meaning the lowercase letters and the uppercase letters that are used in variables are completely considered differently. In the example here, the first example, car, we have used all the lowercase letters for the variable name. In the second example, we have used all uppercase letters for variable name. In the third example, we have used the combination of uppercase letters and the lowercase letters. The compiler considers all these three examples as three complete different variable names. Also, we can have variable names that are constructed with digits and letters. We can have a variable name with the combination of these. Also, we cannot use any of the special symbols other than underscore while constructing a variable name. While naming the variables, we cannot be using keywords as variable names. For example, we cannot use main as a variable name or define as a variable name because they are the keywords of C programming language. And also variable names can be of any length, but it is preferred to have 8 characters, up to 8 characters as the variable length. Now that we know how to construct variable names by using different rules or by following different rules, we also have to know how to declare these variables. Now, every variable in C program must be declared. Now, the syntax of declaring a variable name is data type followed by variable name. Now, you can have a single variable or you can have a variable list. In the example here, int xyz. Now, xyz here are different variables of type integer. All xyz variables will hold only integer values. We can divide this statement into int x, int y and int z, but C program allows you to put all the similar type of variables under one single statement, and thus we can have int x y z, and all the variable names must be, or all the variables must be separated by a comma. Now in the second example, char flat comma ch, flat and ch are the variables of type character. Now while declaring the variables, no memory will be allocated for a variable. Now this happens only after we define the variable. For example, when we say int a, then memory will not be allocated to the variable a. But when you say int a is equal to 20, then the memory will be allocated to the variable a. Now, after declaring the variable, we also must assign the values to the variable. These values can be any constant value, meaning it can have a real value, an integer value, or a character value. Depending on the type of the variable will hold that particular value. Now, initialization of variable means assigning a value to the variable. We also have to assign the value to the variable. Now, assigning the value of variable is done by the syntax, say data type followed by its variable name equal to symbol, or this is how we do the assignment, and the value that we have to allocate or assign to the variable. Now, for example, int x equal to 50 means we are assigning a value 50 to the variable x of type integer. We can also do multiple assignments in a single statement, but here in this example, x and y both should be of type integer. Now in this statement, we are declaring and assigning the values to the variables in a single statement. Now when we say int x equal to 50, comma y is equal to 30, we are assigning 50 to variable x and we are assigning 30 to variable y, and now x and y are of both integer type. In the next example, we are assigning value or character constant value x to flag, which is of type char, and also we are assigning a value capital I to ch, which is a variable name of type char. Now, where can we declare these variables? Can the variables be declared throughout the program? Now, the variables can be declared as local variables or as formal parameters or as global variables. Now, variables are called as local variables when they are declared inside the function. For example, inside main function, if I am declaring two variables, say int a and b, which says a, b are the variables which are of type integer. Now they are called as local variables for the main function, and the scope of these variables will only be within the main function. We can also use variables, or we can also declare variables as formal parameters while defining a function. We can declare variables outside the functions wherein these variables are called as global variables, and the scope of these global variables will be throughout the program. Thank you, as we have reached the end of the session.